Good day. Let's do some division here, some Vedic Math division and a digit sum check to check the answers for accuracy. Okay, what we're going to be doing is dividing here these numbers that we have here. And these numbers are close to a base number being 100. Okay, so these numbers are very close to the number 100. You can see 95 is close to 100, 96 is close to 100, 93 is close to 100, etc. So the technique we're going to be using today is division below a base number, and then we'll be doing the digit sum check to check our answers for accuracy. Okay, first problem, we have this here is our dividend. This is our divisor, and we can see that the divisor 89, we can see that that's close to the base number 100. So here's kind of how we're going to set this up. We just kind of draw a line like this. We could draw the number 89. Now we need to find the complement of 89. Now to find the complement, we're going to be using our formula all from 9 last from 10. So 9 minus 8 gives us 1, and 10 minus 9 gives us 1. So 89 and 11, okay, these are complement numbers. 89 and 11 are complement numbers. And when I add these two numbers together, I'm going to get the base number 100. Okay. Now also note that there's 2 zeros in the base number. So what we're going to do is we're going to go 2 digits in from the right. Okay, 2 digits in. And we're going to draw a line like so. Okay, everything on this side is going to be the remainder. Everything on this side is going to be the quotient. Okay, quotient and remainder. Now the first step what we want to do is we want to bring down this first number here, the number 4. Okay, now I'm going to take the number 4 and I'm going to multiply it by the complement number here, 11. So 4 times 11. 4 times 11 gives us 44. We're going to write it like this, 44. Okay, 2 digits at a time. Now what we want to do is we want to add up this column here, 0 and 4, and then bring it down. So 0 and 4 gives us 4. Okay, once again, we take this number 4. We're going to multiply it by this complement number here. 4 times 11. Now that gives us, again, 44. All right, and now we're going to add this column. Okay, 1, 4, and 4. That's 9. So we're going to bring this number 9 down. 9. Now we're going to we're going to multiply 9 times 11. 9 times 11 gives us 99. Okay, and you notice that each time I'm doing this, I'm kind of sidestepping every time. Okay, we started here, bring down the 4 times this 11 gives us 44. Now we bring down this number here, 0 and 4 gives us 4 times 11 gives us 44. Notice that we kind of just jogged it to the right here. Okay, we do that every time. We just kind of jog it to the right. So now all that's left, okay, we get to the end. When you get to the end when you have a number here in this very last column. Okay, this very last column here. So all it's left to do basically is to add these up. Add up these columns. So 1, 9, and 4, that gives us 14. And 9 and 9 gives us 18. Okay, now I want you to recognize that here we have the tens place. Okay, and our remainder. Here we have the units place. Okay, remember, everything on this side is the remainder. Everything on this side of this line here. Everything on this side is the quotient and remainder. Okay, also in the quotient, here we have our units. Here is our tens place. Okay, and here's our hundreds place. Okay, the reason I'm pointing this out to you is because we added this column up and we got 14. So we have 14 tens. That's 140. Okay, we also have 18 single units. So you only really have room here for numbers 0 through 9. So anything greater than 10, there needs to be a carryover. So we're going to say that our quotient equals 449 and our remainder equals, okay, remember we're going to carry this over, 158. Okay, 449 with a remainder of 158. All right, now also notice that our remainder, 158, is greater than the divisor, 89. So we still have room for another for another 89 in here. We got our remainder. Our remainder is greater than the divisor. We still have room for one more. So let's go ahead and subtract 89. Okay, that gives us 69. Okay, so this extra 89, we have one extra 89. We're going to add that back to the quotient. So our new quotient is 450, and our remainder now is 69. And this is going to be our answer here. 450 with 69 left over. When I take this number and I divide by 89, I get 450 with 69 remaining. So now what I want to do is I want to go ahead and do the digit sum check to make sure that this answer is correct. Okay, we're going to be doing a few more of these problems. If you don't have this already written out, all these steps and everything, go ahead and write it out. I'm going to start erasing this stuff. So if you want, go ahead and put it on pause and just write everything out. If you've been following along, I'm going to go ahead and start erasing now. Alright, and here was our original problem. So what we want to do here for a digit sum check. Okay. Now remember that it's going to be when you divide something, okay, you have a dividend. Okay, this is our dividend. This is our divisor. Okay, that you basically have the quotient times the divisor plus the remainder equals the dividend. Okay, in other words, if I take this number 450 times 89 and then I add 69 to it, I'm going to get the original number that we started with. Okay, that's quotient times divisor plus the remainder equals the dividend. This is our formula for the digit sum check. Alright, and to do the digit sum check, if you've seen my video on digit sum or digital root, you know how to do this. Basically, we're going to be adding up the numbers until we get a single digit left. So, the quotient here, we have this number 450. If I add 4 plus 5 plus 0, that gives me 9. So 9 is the digital root of 450. So we're going to say the digital root of the quotient is 9. Okay, now the digital root of the divisor, here's our divisor. Okay, 8 and 9, if I add 8 plus 9, that gives me 17. And then I keep going. 1 plus 7, that equals 8. So the digital root of the divisor is 8. Remember, when you're taking the digital root, when you have a number, you just keep adding, okay, until you get one number left. In this case, we have the number 8. Now the digital root of the remainder, okay, the digital root of the remainder, 69, that's going to be 6 plus 9. 6 plus 9 equals 15. Okay, further taking the digital root, 1 plus 5, that equals 6. So you can see that our digital root for the remainder is the number 6. Okay, now we want to take the digital root of the dividend. Okay, here's our dividend. We want to take the digital root of the dividend. We have 4 plus 1 plus 1 plus 9. Okay, when you're taking the digital root, you could always just cast out 9s. So we can see that the digital root of the dividend equals 6. Alright, now here's how we go about doing this. We're going to kind of do this. We're going to take 9 times 8 and add 6, and then we're going to take the digital root of that number, and we're going to see if we could get it to match. So 9 times 8 is, what, 72. Okay, 72 plus 6 equals 78. Okay, taking the digital root of 78, 7 plus 8, that equals 15. Taking the digital root of 15, 1 plus 5, that equals 6. So you can see I've taken the digital root, and this is what I get. Okay, so the digital root of the dividend is 6. The digital root of the quotient times the divisor plus the remainder is also 6. Okay, these two numbers match. Okay, this is the idea of a digit sum check. Now, I could say with fairly good confidence that this answer is correct, 450 with a remainder of 69. And the reason I could say that that's confident is because these numbers when I do this digit sum check, they match out. Okay, they're match. Now, if these numbers did not match, let's say that this number that I got down here was a 5 and this number was a 6. Okay, if they don't match, okay, when they don't match, then you know 100% that it's wrong. Okay, if they don't match, you know that you got it wrong. So this technique doesn't really tell you when you get it right. It tells you when you get it wrong, if that makes sense. It doesn't tell you that you got it right. It only tells you when you get it wrong. So we don't know that it's right. We could say with fair certainty that it is right, but if they did not match, if these numbers did not match, then you know 100% that it's the wrong answer. So we're going to go ahead and say yes, this is the correct answer, 450 with a remainder of 69. And we'll just continue on. So let's go on to the next problem, and we're going to work out another one of these division below the base and then do digit sum check. I think you'll start to get the hang of it. All right, our next problem, 19,897 divided by 95. Now we can see that this number 95 is close to the base number 100. Okay, 95 is very close to the base number 100. So let's go and set up our problem once again. We're going to kind of set it up like this. We're going to write our divisor. Our divisor is 95. We're going to take the complement of 95. Remember, to take the complement, we use our formula all from 9, last from 10. So 9 minus 9 is 0, and 10 minus 5 is 5. Okay, these two numbers are complement. 95 and 5 are complement numbers. When I add them up, 95 and 5, I get the base number, 100. Also note that in the base number here we have 2 zeros. So that means 2 digits in from the right, we're going to draw our line for our remainder and our quotient. All right, to start this off, we're going to bring down this number 1. Okay, we're going to take the number 1, we're going to multiply it by 5, 0, 5. We're going to do this 2 digits at a time. Okay, 2 digits here, we're going to be writing 2 digits at a time. So 1 times 5 is 5. We're going to write it like this, 0, 5. Okay, bringing down the next column, 9 and 0. 9 plus 0 gives us 9. So we're going to take this number 9 here, multiply it by 5, 0, 5. 9 times 5 gives us 45. All right, now we're going to add this column, 8, 5, and 4. That's 9 plus 8. 9 plus 8 is 17. So we're going to write it like this, 17. Okay, notice that this column here, okay, we have a number that's bigger. You only have room for 0 through 9. So this 1 is eventually going to be carried over. Okay, we'll wait till the end to do this. This 1 we're going to carry over. So we could go ahead and draw like a little carryover like this. Okay, that's kind of why I write the 1, a small 1. Let you know that that's going to be carried over. Okay, so now we have this number 17. We're going to do 17 times 5. Okay, 17 times 5. 17 times 5 gives us 85. Okay, and at this point, you know you're done because the number here that we've written in is in the very last column. We don't need to go any further out. This is the last number that we written in here. It's lined up with the last column. All I have to do is to add these columns up now. So 9, 5, and 8. Okay, that's 14 and 8. 14 and 8 gives us 22. Okay, 7 and 5. 7 and 5 gives us 12. Now, once again, this is the tens place. Okay, this is the units place. In our quotient, this is the units. This is the tens place. And this is the hundredths place. Okay, so why am I showing you this? Once again, the tens unit, we have 22 tens. Okay, that's 220. 22 in the tens unit. We have 12 in the single units place. Remember, anything more than 10 we need to carry over. So this 1's going to be carried over here like this. So here we have our quotient. Okay, doing our carries. It's going to be 207. Okay, our remainder doing our carry gives us 232. And once again, notice that the remainder is greater than the divisor. Okay, 232 is greater than 95. So we have room for a couple more 95s that we're going to throw in here. Okay, you can kind of see that we have at least room for 2 more 95s. Okay, because 95 times 2, that gives us 190. Okay, so we're going to take 232 minus 190. That gives us 42. Okay, so these two extra 95s that we have here, those are going to be added back onto the quotient. So we have our quotient now, 209. See, we had 207, but we have room for two more 95s, so we add those on. 207 plus 2 gives us 209, with a remainder of 42. Here's our answer, 209, remainder of 42. All right, and what we want to do now is our digit sum check. So once again, if you don't have this already written out, go ahead and write everything down, all these steps that we have here. And go ahead and put it on, press pause. I'm going to go ahead and start erasing this stuff. All right, so here's our question. Here's our answer, 209, remainder 42. So remember that it's quotient times the divisor plus the remainder equals the dividend. Okay, 209 times 95 plus 42 equals the original number that we started with. So now let's do our digit sum check. Let's take the digital root of the quotient. Here's our quotient, 209. Okay, the digital root of 209, doing our casting out nines, we could see that that's just a 2. Okay, times the digital root of the divisor. Here's our divisor. Once again, just casting out nines, we could see that the digital root of 95 is just 5. Plus the digital root of the remainder. Here's our remainder, 42. Taking the digital root, that's just 4 plus 2. 4 plus 2 gives us 6. And finally, the digital root of our dividend. Okay, doing casting out nines, we can see there's a 9, 8, there's a 9, 1 and 8 is a 9, and there's another 9. We can see that our digital root of our dividend is just 7. Okay, so now let's multiply these out and add this number here, and then take the digital root and see if that matches with the digital root of the dividend. So 2 times 5, that is 10. 10 plus 6, that gives us 16. Taking the digital root further, 1 plus 6. 1 plus 6 equals 7. Okay, you can see these two numbers match. Okay, and once again, just because the numbers match doesn't mean that you got it right. But let's say these numbers did not match. Okay, then you would know that it's wrong. So once again, taking the digital root, doing this digit sum check will only tell you if you get the answer wrong. Okay, but since they did match, I'm going to say with a good certainty that this is the correct answer. Okay, with a fairly good certainty that this is the answer. Once again, if these numbers did not match, then I would know for certain that the answer is wrong. Okay, digit sum check only lets you know when you get it wrong. It doesn't tell you when you get it right. It just tells you when you get it wrong. All right, so let's do another problem. We have 2 more problems to go. I think you'll start to get the hang of this. All right, here's our next problem here. Now you can see that the divisor here, 96. Once again, that's close to the base number 100. Okay, so let's set up our problem here. Let's kind of draw our lines like this. We could write the divisor here, 96. going to find the complement using our handy formula, all from 9, last from 10. Okay, so 9 minus 9 is 0 and 10 minus 6 is 4. Okay, these two numbers are complement numbers. Once again, complement numbers when added together, if I add 96 and 4, I get this base number 100. Also note once again that there's 2 zeros in the base number, which means that we go in 2 digits from the right to draw our line separating the quotient and the remainder. All right, step number 1, let's bring down this number here, this number 2. Maybe not so far down, maybe, how about here, 2. Okay, now we're going to multiply 2 times 4, writing 2 digits at a time. 2 times 4 gives us 8. I'm going to write like this, 0, 8. Okay, next column, 4 and 0. 4 plus 0 gives us 4. So now let's take this number 4, multiply it by 4. 4 times 4 gives us 16. Okay, writing in 2 digits at a time. Now adding this column, 5, 8, and 1, that's 9 and 5. 9 and 5 gives us 14. Okay, once again, remember that we only have room for numbers 0 through 9, so anything greater than 10 is going to be a carryover. So we could write this little arrow like this, letting us know that we're going to carry that number 1 over. Okay, so 14 times 4. Now we have 14 times 4. 14 times 4 gives us 56. Okay, and at this point we're done because this last number here lines up with the last column. So now adding these columns together, we have 8, 6, and 5. Okay, that's 11 and 8. 11 and 8 gives us 19. And then 3 and 6 gives us 9. Once again, here's our tens place. Here's our single unit digits place. Okay, here's our hundreds place. Here's our tens place. Here's our units place. Okay, so what that means is that we have 19 in the tens place, so 19 times 10 and 9. So we have our remainder. We can see that our remainder equals 199. Now our quotient, okay, we have this here, 2, but remember this carryover, so 254. So our quotient is going to be 254, remainder 199. All right, so this is the answer that we got using our technique here, division below the base. And you notice that the remainder, our remainder here, 199, that there's still room for another 96. Okay, in fact, there's room for 2 more. So let's see, what's 96 plus 96? 96 times 2. 96, 96. Okay, that's a 2, carry a 1. 192. Okay, so 199 minus 192, that gives us 7. So these 2 extra 96s that we just did, remember we had 96 times 2 gives us 192. Okay, so here's the first one, here's the second one. We need to add those back onto the quotient. So now our quotient for our answer, we're going to say the quotient equals 256, and the remainder equals 7. Okay, here's our answer. 256 with a remainder of 7. Now we're going to go again, once again, we're going to go through the digit sum check. If you don't have any of this written out, go ahead, press pause, write this stuff out. I'm going to go ahead and erase it, and then we'll work on the digit sum check. Alright, so here is our problem and here is our answer. Once again, remember that it's going to be quotient times the divisor plus the remainder equals the dividend. Okay, so let's take the digital root of the quotient. Here's our quotient, 256. Okay, taking the digital root of 256, you're just going to add 2 plus 5 plus 6. Okay, that's 2 plus 11. That equals 13. Now let's keep going. Remember, when you take the digital root, you just keep adding numbers until you get one number left. So that means 1 plus 3, that equals 4. So our digital root of the quotient is 4. Okay, the digital root of the divisor. Here's our divisor, 96. Taking the digital root's easy, just going to cast out this 9. So we can see that our digital root is going to be 6. Now the digital root of the remainder, here's our remainder, 7. Digital root of 7 is just 7. Okay, now the digital root of the dividend. Here is our dividend. Okay, casting out 9s, 4 and 5 is 9. So that leaves us 2 plus 8 plus 3. Okay, that's 10 plus 3, that equals 13. Once again, taking the digital root further, 1 plus 3, that equals 4. So here's our digital root of the dividends. That's going to be 4. All right, 4 times 6, that gives us 24. 24 plus 7 equals 31. Taking the digital root of 31, 3 plus 1, that equals 4. Okay, you can see that these two match. So these two match. So once again, if they didn't match, let's say that for some reason I got a 4 here and a 5 here. You know, if these did not match, then I know it's wrong. So this doesn't tell us that we got it right. Doing this digit sum check will only let you know that you got the answer wrong. Okay, I can't stress that enough. And the reason for this is you know, you could just add another 9 in there and it kind of messes things up. So let me just kind of say this to clarify, not to confuse you, that if they do not match, then you know 100% that it's wrong. Okay, if they do not match, then you know it's wrong. Okay, so we could say with fairly good certainty that we got this answer right. Here's our answer, 256, remainder 7. We're going to go ahead and say with fairly good certainty that this is the correct answer. And one more problem to go. I'm sure you guys are doing well. This is a really good technique to check your answers. Do your division, doing this Vedic math, division below a base number, and the digit sum check. This is a really good technique, and I hope you guys are learning how to do this. All right, and here it is, our last problem. 85,554 divided by 93. Once again, we see the number 93 is close to the base number 100. So let's set our problem up kind of like this. We write our divisor here, 93. Okay, let's take the complement of 93. Remember our handy formula, all from 9 last from 10. So 9 minus 9 is 0. 10 minus 3 is 7. Once again, these two numbers are complement numbers. That means when we add 93 and 7, we get this base number 100. And since there's 2 zeros in the base number, we move in 2 digits from the right and draw our line separating the remainder and the quotient. All right, to kick this one off, we're going to drop down this number 8 here. Okay, then we're going to take the number 8 times 7. 8 times 7 gives us 56. Okay, now adding this column, 5 and 5. 5 and 5 gives us 10. 10 times 7 gives us 70. Okay, 5 and 5 gives us 10. 10 times 7 gives us 70. Remember, sidestepping each time. So now adding this column, 5 and 6 is 11. 11 and 7 is 18. Okay, 18 times 7. 18 times 7, that gives us 126. 126. Okay, now the reason I write this 12 here, this is 120. Remember, this is 12 tens. Once again, this is the tens place. This is the single units place. So if I do 18 times 7 gives me 126. I have to write it like this. 12 in the tens place. There's your 120. 6 single units. Here's 126. Also, we know we're done because this column here is the last digit. Kind of matches up here. All that's left for us to do is add these columns up. So 5 and 12 gives us 17. 4 and 6 gives us 10. Okay, now we can kind of do these carries. So our quotient, here we have 9, 1, 8. Our remainder, this 10 is going to carry over. We have 1, 8, 0. Okay, 918 with a remainder of 180. Now notice once again, our remainder is greater than the divisor. 180 is greater than 93. So let's take 180, let's subtract 93. What do we get? 87. Okay, this extra 93 that we just subtracted, we're going to add that back on to the quotient. So our quotient now equals 919. Our remainder equals 87. Okay, this is the answer we get. 919 with a remainder of 87. All right, we're going to do our digit sum check. Once again, if you don't have any of this written out, go ahead and write this stuff down. I'm going to go ahead and erase it. Go ahead and press pause. I'm going to go ahead and erase through this stuff, and then we're going to do our digit sum check. All right, here's a problem that we started with. Here's our answer, 919, remainder 87. So we have the quotient times the divisor plus the remainder equals the dividend. Okay, the digit sum of the quotient. Here's our quotient, 919. Doing our casting out nines, we see that the digit sum is just 1. Okay, times the digit sum of the divisor. Here's our divisor, 93. Casting out nines, or doing our digit sum, we can see that the digit sum of 93 is 3. Plus the digit sum of the remainder. Here's our remainder, 87. So we have 8 plus 7, that equals 15. Taking it further, 1 plus 5 gives us 6. So the digit sum of the remainder is 6. And the digit sum of the dividend, here is our dividend. Taking the digit sum, we could cast out nines. There's a 9 there. Okay, so we have 5, 5, and 8. Basically, we're adding 8 plus 5 plus 5. That gives us 18. Okay, taking the digit sum of that, 1 plus 8. 1 plus 8 gives us 9. So the digit sum of our dividend is 9. Okay, let's do this. 1 times 3, that gives us 3 plus 6. 3 plus 6 gives us 9. So you can see that these two digit sum checks check out. And just kind of want to keep reminding you that if they don't match, okay, this is important. If they don't match, then it's 100% wrong. Okay, this isn't going to tell you that you got it right. It only tells you when you get it wrong. So we could say with fairly good certainty that this is the correct answer, 919, remainder 87. Alright, you made it to the end of this video on Vedic Math division below a base number and the digit sum check. I want to thank you for watching my video. Please hit the like button down below if you want to leave a comment. And if you like these type of videos, you want to see more, simply subscribe to my channel for more. Thank you.